Good afternoon, everyone. I'd like to welcome you to our session today, webinar called Process Setup and Calculations. I am BJ Yoder. I'm in the Tech Support Department here with Allmax, and I'll be conducting your webinar. Allmax Software wants to thank everyone for signing up. Most attendees have signed in, so we're going to go ahead and begin our webinar. I want to go over a few introductory items for the webinar. We have multiple attendees, so because of this, I have muted everybody. We encourage you to ask questions by typing them into your chat window. We have text on standby to answer your questions, and every attendee will receive a transcript of those questions with responses. Keep in mind we are conducting this webinar online, so if any internet-related delays or interruptions occur, this will not affect the recording. Everyone will be receiving a recording of each of the sessions, so do not worry if you get pulled away from your computer or miss a particular section of the webinar. As we discussed last time, we were talking about the general overview of process. In the Operator 10 program, we have processes available to be used to create calculations in your program. So just a little overview of what processes are. Again, it's the key part of any treatment plant operations. Water and wastewater treatment facilities are made up of all sorts of different processes. And in these processes, again, the key part of that is the efficiency, how that process is being ran, which in turn lets you know how your treatment plan is doing. For your removals, your percent removals, loadings, even getting down into the point of detention times in tanks, or even to the point of being able to calculate cost on chemicals used during a process. So for example, if in a disinfection process you're adding chlorine, you could go and define the chlorine in the program, and you will be able to go and calculate the cost based on the definition of that chemical. Some other things that are done inside process is we allow you to go by the definition of the program, allow you to create calculations so you don't have to write formulas to get that information. So as we go through here, for example, in water treatment, in the water program, we have these main processes available with the types of treatments underneath it. For example, we have pre-treatment, treatment process, a treated water, solids handling, and an efficiency process. Those 5 processes then have different types of things that can be defined in them. So for example, under pre-treatment, you can do a sedimentation or an aeration portion in your water treatment process in the water program. Now in wastewater, we have considerably more because of the type of system it is. So for example, you can have preliminary, a primary, a secondary. We can also go into tertiary, disinfection, efficiency, and solids handling. Each one of these, again, having their own type of treatment subcategories per se. So as we go through here, one of the big things is, well, what do we need to set up this process, and how is this going to be set up? What we're going to do today is we're actually going to walk through the process setup of a treatment of the program itself. We'll be doing the steps right online as you go through. But the first thing you're going to need is you need your data. You need to know what locations and parameters you have associated with your particular treatment plan. In this sample that we're using today, we have a couple influent flows. So we do have a domestic and industrial flow. We have our raw influent, which is a combined information of lab data, our final effluent, which is lab data and flow. We also have stuff at the aeration tanks. So we have our DOs, or settled solids, our mixed liquor suspended solids, our volatile solids. And we even get down into our clarifiers with our depths of blankets, our RAS information, and our WAS information with our flows and concentrations. This information here will then be used to create the process that is being developed in the program. This is all the base information. So as we go through the program and as we look at this, you will be able to see how this all turns into play. So the first thing we need is, like I said, we need your data. Secondly, what we need is, your next step would be to have some sort of a plant diagram available to you. In this case here, this is an example of what you may want to come up with, but the idea is so that you can determine what type of processes you have in your treatment plant. We're going to be dealing with a wastewater treatment plant today, so in a wastewater treatment plant, process-wise, you may have several different types of processes in it. You may have a primary process for your primary tanks. You want to see removals and efficiencies during that section of your plant. You may also have your secondaries, which could be aeration basins, could be your trickling filters, your clarifiers. Again, that information is going to be there. You're going to want removals and stuff based on that type of a process. Now, process, as we go through here, one of the things to remember is all treatment plants, when they're designed, they have design criteria that they have to meet to make sure that that plant is working efficiently. So, for example, you may have a BOD removal of a certain percentage that you have to meet. In your aeration tanks, you may have to have an FM ratio or an MCRT of a certain value to make sure it's running the best and optimal as it can. Now, that varies from plant to plant, but the idea is what is the information you're going to need to generate that. Operator 10 can generate all that information based on the criteria that you designed for it. You will also need, besides your plant diagram and your data, you'll also need tank volumes. You'll need your sizes of your tanks. So like on clarifiers, you're going to need your volume, your surface area, your weir overflow rate, weir overflow, because that information is now going to be defined in the program so that you can get the information based on that. So as we set up the process, how this works is we actually go into Setup. In your menu on the main screen, you will go to Setup and you will go to Process. Process will allow you then to bring up information on how this is set up. So we will do a brand new one. And this is our process editor. This process editor will allow you to define everything about this given process we're doing. So for today's example, we're going to do a secondary process. So the first thing you're going to define is what facility you're in. For those of you who have multiple, you can set up multiple processes for different facilities. So we will pick our process. We're going to pick our process type. And again, since we're doing it wastewater, we're actually going to pick a secondary process. Now, the next thing that we need to define is a process location. This location is a location that is defined in the program, but the whole idea behind this location is you do not enter data into this location for the most part. There are a couple exceptions. But this location does not have parameters attached to it. This one here, think of it this way, as a file cabinet. It is here to store information only, not to enter data into. One of the biggest mistakes that we see people try to do is they pick a location that already has parameters attached, and in doing so, some parameters will get overwritten with values. Sometimes the process itself will not work. So I always like to keep this process location completely empty of data entry. Now, here is the exception. If you are doing a process that has chemicals added to it, and you want to track the dosage rates or the chemical cost to that process, at that point you would attach the feeding, for example, disinfection. I want to track the chlorine pounds that I use. Well, I would enter the chlorine pounds parameter at this process location. That is the only exception, is chemicals. Everything else we try to leave out of there. So when we go into process location, we click the ellipses button, and it'll bring up our location list. Most likely at this point you do not have a location defined. So what we will do is we will create a brand new location. In this case, because we do have biosolids loaded on this program as well, we are actually what type of a location? Well, this is going to be a standard location. So when we hit OK, we're going to give it a location name. One of the things that I like to do is I like to go and define this location name with the letters PR in it for process. So my description will be secondary process. And again, the reason I do that is just from the standpoint of making it easier to find if I'm searching later down the road. If I'm searching to add location parameters to data view, I can search for process. And again, we will pick the facility that we're wanting to use. And then we'll save that location. Now that it is saved with the success, we can close it. And we will now select that location name, the secondary process location name. The next step is to determine what is coming into the process. How are we basically what we're wanting to do here is how to calculate the flow, the pounds coming into the process. So there's some options. One of the things that we do here is we give you 6 variables that you are allowed to define. So if I have a influent flow for my industries, and I do lab and flow there, I can define it. If I have a bypass flow, so maybe I take information out of my main flow and I bypass it from the main plant, and it gets bypassed to a equalization tank, for example. We could then go and define that and subtract that flow and pounds out of there and milligrams per liter out of there, so that I remove those pounds because they're technically not coming into the plant. Again, that just gives you some options. In our scenario, we actually had 2 influent flows. So what I would do first of all is I'm going to pick my domestic flow. I'm going to pick it. I'm going to select that it is a flow plus. Now, I do not have any lab data or lab parameters at this location, so I do not define any BODs or suspended solids or copper, lead, nickel, whatever at this location. It is fine. We're going to move on to the next one. I need to go, and I have a second one. I also have an industrial flow. So at this point, I will come in here and I will pick my industrial location. Again, just like with the domestic, I do not have any lab data associated with this location. So all I will do is pick flow. So basically what I'm doing is I'm adding these 2 flows together. If you look right up here under the source status, it tells you what is happening. So I'm getting domestic flow and industrial flow and adding them together. This will give us some process influent data. Now, my lab data that I need to calculate my loadings coming into this process, I can then come in here and I will use my raw. My raw influent, is where my lab data is actually saved. I actually save my BOD results there, my suspended solids, my copper, lead, nickel. All my concentrations are here. Now, I don't have any flow associated with that because that's what the first 2 handle. I'm not subtracting it out, but I do have lab data there. So now what I have defined here is basically my domestic flow plus my industrial flow. in million gallons a day. I'm going to multiply, the program will multiply those by 8.34 times the concentration of whatever parameter I'm looking at, whether it's BOD, suspended solids, whatever. That will give me my loadings for this given process. So what is coming into the process? Now, the next step is to define the effluent of the process. So what we determine here is what is the next sampling point for basically the same thing that I'm sampling here at this raw location. What is my effluent, what is my next sampling point of those same parameters? So in this case, my next true sampling point for that is going to be my final effluent. So we'll select it. So now based on those set up right there, we can now get our loadings, our removals, our percent removals, our pounds left in the effluent, and also our kilograms left in the effluent. We'll go over that a little bit more here in a little bit once we see the setup. But based on this setup that I have right here at the top, that is all that that's going to give us right now. Now, we want to go one step even further. So the next question here is, how am I doing the flow into my different sections of the process? So going into each of my tanks, how do I determine that? Well, most treatment plants, a percent of process flow, influent flow, works just fine. Now, some treatment plants do have, some of you may end up having a flow meter at each of your tanks, so you can truly determine what that is. If so, you will be entering that into the program anyway. So at that point, you could select the section flow meters. But either way, works well. I like to use the percentage because it's pretty close. We're going to be good on most of those. So next, we're going to add sections. Now, sections are, again, the individual tanks, which there may be sampling for it. So, for example, on my aeration basins, I sample for my DO, I sample for pH, I sample for my settable solids, I do my mixed liquor suspended solids and volatile solids at both of those. So at that point, I can go and add these different type sections. So when we hit add, again, these are ones that we've already defined in the program already because we're already entering data. So I pick aeration tank number 1. At that point, I come up here with the next information, and I'm going to say what type of section this is. In this case, it is an aeration tank. Again, if you're doing a contact stabilization, you would have a contact tank, you would have a stabilization tank. But it's all up to the process that you have. So I picked my aeration tank. Well, I have 4 aeration tanks, so I figure for the most part, 25% of the flow goes into that. Okay, so then we're not going to worry about this out of service and section summary. I'll get to that in a minute. But then we want to do the volume. So we're going to say it's 2,500,000 gallons is our size of our tank. So at this next point, then I can come in here and I can add my next tank. Again, we're going to go with number 2. It's an aeration tank. It's getting 25% of the flow. Same size again. And it will be gallons. And then we'll add the next one. Again, this is a repeat process. This is one of those things that as you set these up and as you determine these inside the program, again, there's going to be information associated with it. And then we'll get our last one, our last tank here, which is our last aeration tank. Now, the next step, what I like to do, and because of how the program works, sometimes you're going to want a summary location. I like to, if I have multiple tanks of the same type, so in this case I have 4 aeration tanks, I like to go and add a summary location. This summary location, just like the process location, is going to be a file cabinet. It is going to be where we are storing data. This will give us the ability then to go and store summarized information on those aeration tanks. So with that, a summary location, I'm going to get my average DO. I'm going to get my average pH, my average mixed liquor suspended solids. I'm going to get my total pounds in inventory for all 4 tanks. Again, the idea is to just summarize that information. Also with that, as we go in and we add, of course we don't have one here, so then we will want to create a new one for our summary location. Again, it's going to prompt us for the same question, and it is going to be a location. I like to go, and when I create these, I like to put SM in here, because that way I know it is a summary location. Again, just my preference on naming. You can name stuff however you wish. That's the benefit of the program. You can define them how you want. And so when we save it, I now have a summary location. So when I hit OK on it, I can then come here and I will say it is an aeration tank because it is summary, but the next thing I do is I come down here and I check the section summary only for this one. Now, because of this being a summary location, we are also prompted for some additional information. This additional information then will be used to do other types of calculations. For example, our section detail, we are prompted for what is our RAS location. Pretty simple. We're going to pick our return activated sludge. Waste mixed liquor. If you had a waste mixed liquor, you could define it here. If not, go on. I have a waste activated sludge, so WAS location. Now, here's a little trick. Some people have 2 WAS locations. If you do, you could technically put one of them here in the waste mixed liquor and one of them here in the sludge removed. It'll give you a total of those 2 as it does the calculations. Just a different way of doing that. But with this information, we're going to get additional information because we are able to define this. If we would not have done a summary location, you would have never seen this. So that's why it's very important to add that summary location into the program itself and to define that as you go. Now, the next section of this is to add our next sections in the process. In this case, we have clarifiers. So I'm going to add a clarifier. Again, select clarifier. We're going to go 33.3 because we're assuming they're the same. And again, some of these volumes may seem a little kind of crazy, but we're just going to put some numbers in here to give us some values. And these are our gallons, our square foot, and our feet, our weir length. Again, we'll add a second one, our second clarifier. Give our percentage. Now, as we're doing these percentages, one of the things that is beneficial is how this is determined. The percentage, again, we always do a default as percentage. Here in a minute, I'll explain how this in and out of service actually works. I'll show you where you can actually change it easily. How this in and out of service actually handles it and why we have it is because we're able to go in, and if we take a tank out of service, because sometimes you guys will be working on a clarifier because the rotor arm or something went down and you have to go and change the squeegees on the bottom of the tank, or you got to change a motor or whatever, a gearbox out, whichever. Well, by taking it out of service, you don't have to come in here and change this percentage. It automatically, if I take clarifier number 3 out of service, it'll take that percentage and divide it by the other 2 same types. So in this case, if I took number 3 out of service, number 1 and number 2 would then get 50% of the flow automatically. And as long as it was out of service, it would get that. Once I put it back into service, then of course it would go back to 33 1/3 for all of them. Again, just like we did with the aeration basins, I like to go and I like to add a summary location. Because of, just like I just said, with if I have tanks in and out of service, that average may be different, for each of them. So you may not get with 33 1/3, if I split it to 2, of course, the flows and stuff will be different on those individual ones. So we will create a summary location here, save it, and we now have a clarifier summary. And we will do the same thing as we did with the aeration tanks. We will change it to clarifier, but we'll save section summary. Now in this case, there is no additional information available is needed for this particular process on that clarifier. Now, what we have done, if we go in and we look at your flow diagram that we were looking at earlier, we have defined this process. We have defined everything associated with it. We just defined our influent, we defined our effluent, we defined our individual sections, so our 4 aeration tanks and our clarifiers in here. So now what do we get? What do we get to see and what information do we get? At this point, what we're going to do is we're going to click Save, and then we're going to hit Create Calculations. This Create Calculations, what it does is it goes and gives us a list based on the information of everything we sample, different types of information. So for example, we just kind of run down through this list, we'll see what we have. First of all, at each of those sections, since we do not have a flow meter at those, we will actually create a flow in million gallons a day at each one of those sections. So all 4 of the aeration tanks and the clarifiers, it will actually get determined a flow value for that information. So we're going to create that. So we'll take our total plant influent flow and we'll divide, like on aeration, for example, we'll divide it by 4 and put it into that much into each one. Again, this is where your percentage comes into play. If for some reason we take one of the aeration basins out of service, well, it would now be each one of the tanks would be getting 33 1/3% of the flow instead of 25%. Next, what you see in the list is you see our secondary process. Remember, this was our file cabinet. We didn't define any parameters at this location. Now, what we get here is based off of the information that is defined in the influent of the plant and the effluent of the plant. We're going to get different parameters. First of all, we are going to get a flow parameter there. So it will actually take and calculate that total domestic flow and the total industry flow in million gallons a day and calculate it together in there. So if you didn't have those combined anywhere, it'll actually do it for you. Next, what you will see is a list of parameters. These list of parameters are based off of what are sampled at both the influent and the effluent. They have a tilde in front of them, and then they have an L, an R, a P, or X involved there. Now, with that, what this gives you is this. The base parameter, so for example, here on our first one here, we have a tilde L BOD 5. We sample for BOD at the influent. So at this case, we're going to get a pounds loading at the influent. We're then going to get a pounds removed because we sample at the effluent, so we're going to get a pounds removal. We're going to get a percent removal on that. And we will get the pounds in the effluent. Now, here's something to remember. If for some reason you do not sample, say you sample in the influent, but you don't sample for that parameter in the effluent, all you will get is your pounds loading, your tilde L, and the parameter. Say, for example, all I do is TKN at the influent. I don't do it at the effluent. At that point, I would get a tilde L TKN, which would be pounds loading. Now, if I sample at the effluent also, of course, then you'll get all four of them. You'll get the loadings, removals, percent removals, pounds left. Now, if I sample at the effluent, but I don't sample at the influent, well, because of the way the program is, I'm not going to get any of those. I won't get even the pounds loading in the effluent, because how the program works is this. It looks at the loading, it calculates the loading, it calculates what's removed based on what's at the effluent. So if it doesn't have the effluent, because of how it calculates, it won't be there. A suggestion that I always make is go ahead and set your influent and effluent the same with the same parameters. That way you will get them. We can then always come back and write a custom formula to get that loading at the effluent. It's not going to hurt anything to have it. Benefit is, if you do start sampling at the influent for a given parameter, well, you'll already have it set up and you won't have to worry about it. But in this case here, we did BOD, solids TSS, NH3 ammonia, the nickel, the lead, the copper, all at the influent and effluent. And so in this case, we ended up with our loadings, our removals, percent removals, and pounds at the effluent. Now, next, at each one of the tanks or sections, and we're going to start with aeration, there are things that you're going to get based off of the influent, some of the information, the loadings coming into the plant, and what is at the individual sections. Now, what you will see is you will see some of these have asterisks beside them. What that means right at this particular moment, because I haven't created anything, some of this information we may not get. However, a lot of it you will actually end up getting it because it's got to create those other ones first before it can create those. So it's not really sure whether we're going to get them or not. But if you had the correct information in here, you would end up getting this type of information. So if I did airflow, if I tracked the airflow in the aeration basins, I would actually get an airflow in MCF. Because I do a solids TSS and a solids TVSS, or mixed liquor suspended solids and volatile suspended solids, I'm going to get the inventory in that aeration basin. Because I do a settable solids, I will get an SVI. Now, as you're looking through here, as I'm mentioning this, if you look to the right here under dependencies, this tells you what is needed to calculate that information, the parameter. So for SVI, for example, I need settable that parameter called settable solids and solids TSS. If it has both of those at that aeration basin, well, I'm going to get you SVI. If there's something in here you don't see you're going to get that you would like to have and you're not sampling for one of these parameters, well, go add the parameters, recreate, and then you'll end up getting those values. Some of these are a little bit different. For example, FM ratio, I will end up getting FM ratio because I do get the BOD. It's just right at this moment it doesn't see that tilde BOD, this tilde BOD parameter yet, tilde L. The inventory of suspended solids or volatile suspended solids, depending on which one it uses. Respiration rate's a possibility that you can get. Detention time, alkalinity to NH3. We can then get into some process control stuff such as solids loading per 1,000 cubic feet. Again, we're going to base it off of the loadings of the BOD. So with this information, I'm going to get that at each one of those tanks because of the parameters that I sample and the information that I'm actually defining in the program. Now, as we go through here, and we'll get that at each one of the aeration tanks. Now, you remember that summary location that we defined, that aeration summary location, our file cabinet? Well, this is where we get some additional information. So I will get my average dissolved oxygen of my aeration basins, my average suspended solids, my total inventory, my average volatile, my total volatile in pounds. I'll get that total information. Average SVI, average FM ratio. But as we go down through here, because we defined our RAS and our WAS in the setup, we can also get for RAS, we will actually calculate the percent return based off of, because we have an RAS flow value and we know what the flow is going into the process, we will calculate that percent return. We will also calculate flow wasted in million gallons a day. Normally, most people track how many gallons they waste. Well, we'll convert it to million gallons a day, which then also we get some other information here, and we also get an MCRT based off of the inventory and the wasting solids. We will get that information. Then down in our clarifiers, because we added those, some calculated values we would get there. Even though we don't sample for anything except for depth, we can actually get other information, such as our solids loading per day per square foot, our surface overflow rate, our weir overflow rate, and our detention time for each one of those. At that point, because we did do a summary location, we'll get the summary of those, so basically the average of those as well. So when we go through here and we create these calculations, so now once we've looked at this and we've decided this is what we're really going to want, we hit create. It's going to actually add these parameters to the given locations that we showed there. And now we have those available to us. Now, we have not had to calculate any formulas whatsoever. We didn't have to create any custom formulas. The program did all that for us. So with all that we just showed, that I showed you in that list, and I'll go back to it here real quick, this whole list, all these formulas that are used to calculate this, I have not had to write one single formula. So instead of having to write all these formulas, the program created it for me. And it allowed us to do it without that step of writing the formula. Now, once we have the process set up, once we have that set up, our next step is, how do I want to view that information? Well, it's going to be just like any other data view. We're going to just put it on a data view and see the information. So when I go into the data views and we actually come in here, I can do a new data view and I can pull the information that I want to see right out for it. So for example, if I want to see all my secondary process information, this is where my filtering comes into play, because I'm able to go into the grid and just type PR and it shows everything that has PR in it. I can come in here and I can select all this information and I can add it to a data view. Here's what my calculated values would end up being like. This is what they were. You can then go in, just like all your other data views, you can come in here and move these around, place them how you want, and change the headers, do just like you would with any other data view, make it customized to what you want to see. You don't have to show all this information on a data view. If there's only certain things you care about, like all you care about is the pounds at the effluent, well, just put those parameters on here. To see this information, again, how to calculate formulas. There's 3 different ways that you can calculate it. When you're in the data view, we can come in here, we can run calculate, and again, this will be gives us a different way of doing it. So I can come in here and I can pick a date, and we're going to just pick the 3rd here. I'm just going to do it for one day. I'm going to do all the formulas that I want to do for my facility, and I start it. And again, it's going to go through, it's going to calculate for that given time frame. And as you see the formulas going across, these are the formulas that are being used to calculate the information that we asked for. So when we refresh it, of course, we have some of this information in here. And again, this is just our loadings and removals, but all those other formulas got calculated as well. So we were able to see our removals, our percent removals, which is what we're seeing here. Depending on how things are, of course, some of this I don't have values on that given day, so I didn't have anything on that day. I believe it was on the 1st is when I've had values. It would calculate accordingly. But the idea being is this gives you that information. You can then use all these location parameters on any of your data views that you want to. If you have a special report, maybe a custom report, or you want to use it on a report that you have in the report section, you can grab any of that. You can take any of these values then and also add them to a data to a chart. So you could chart your percent removals over the last 6 months if you wanted to, especially if you have fluctuations during seasons. Another way of calculating is out here at the main application. We can actually run calculate here. We can do a calculate now, a month to date, or previous date. It's going to bring up the date window just like the other one did as well. And you'll pick it out and you'll run calculate here. Now, another way of calculating data, and this is one of the things that I always like to have people set up, is especially if they set these up on their server. In that case, if we come in here and we go in and we do a setup schedule, we touched on this last week, but by going in here and setting up a schedule, we can actually come in here and pick a given location, a given server name and database. So I'm going to pick a new server and database, which is going to grab my one that I want, which is what this machine is. This can take a little bit of time. This is why we always go and we suggest that you do this on the server, because once it's set up, it will let you go and grab just that one. So in this case, we're going to grab our process database, and you can set up multiples of these just like we're doing here. And then we can go and we can set up a schedule. This schedule here for calculation schedule, when we click on it, it's going to ask for what facility. If you have multiple facilities, you can set up a different schedule for each one if you want, or you can select them all. Since we have just one, we will grab it. And this here is how many days through the scheduled date will you do it. So if I'm looking, what it does is when it runs calculate, it'll actually look back how many days from here. So if I put a 1, it'll be yesterday's values through today is what it's going to calculate when it runs. Now, with that being said, so if I say I'll just hit 1 for it, I save it, we're then going to create a schedule. We did a new schedule. We do a start time. Benefit to this, I can change this to whatever time I want, especially if you're on a server. Change it to a time there's not a lot of activity on your server. Set it at 1 o'clock in the morning, because you don't want it to have to worry about taking up resources on the server to run it. You can also go in advance. Say I want to run it, I want to repeat the task every 12 hours. I can do so. And we can go ahead and repeat it every 12 hours, and as long as it's running. And so for 24 hours. So basically what it's going to do is give us 2 times every day. So when we hit OK, this now will run, as long as this server is running, it'll run every 12 hours. Every day. So that gives us the ability there. Now, the other things that you show up in the scheduler, and we discussed it, is you can also do the same thing with a backup schedule. We can create a schedule for doing a backup. We can also do an import schedule as well. This import schedule will allow you to bring data in from a text file or a CSV file or whatever, one of the files formats that we have set up that will allow you to bring that information in as well. But set this up. This way your calculations will be ran, in this case, every 12 hours. So as data gets entered, it'll be calculated. Now, the next step, one of the other things is we discussed a very kind of a complex process. Another process that you can do, and this is a very simple one, that a lot of people will come in, and we will actually do a process. I hit the wrong button. Hit process and do an efficiency process. This efficiency process, kind of same steps, just less information. So for example, I can come in here and I can pick a facility. I can go with a process type. In this case, I'm going to do an efficiency. Process location. Remember what I said, this here is going to be a file cabinet. We're going to create a new one, and it's going to be, there's no data stored in here. Overall process. And with our facility name. Once we have it, we save it. We can grab that location, and we can do the same thing. We can go and pick our flow location. In this case, I'm going to do something a little different. I'm just going to do our domestic. I'm not going to involve our industrial. So based on the domestic, again, we'll grab the raw. I'm going to use my domestic flow and my raw lab data. Process effluent location, we're going to do the final effluent. I don't have to worry about this percentage because I have no sections with this. So when I hit save and I hit create calculations, I'm going to get the same information for loadings, removals, percent removals accordingly. But the thing that's going to be nice on this is I'm also going to get, because it is an efficiency, I'm going to get a kilograms at the effluent as well. Now, the reason why we do kilograms, some states, state of Ohio, for example, they're required to track the kilograms in the effluent. That's what one of their permit limits is. So with that, it will give it to us without having to write any formula for it. But this here is based off of just the way we set it up. This is all based off of just the domestic flow coming in. So I'm going to basically take my domestic flow value of 1 million gallons a day times my concentrations in the raw to get my loadings. Final is still going to be the same. It'll still use the same way. Now how the final works, just so you, one of the things I forgot to mention is how final is calculated is this. If there is a flow in 1 million gallons a day at the effluent, at the process effluent, it will use that flow in 1 million gallons a day. If there is not, then what it uses is the flow coming in from the influent. We're assuming that the influent flow and the effluent flow are the same. If they aren't, then you'll have two different flow meters. You'll get values based on the flow parameters at that. Okay. So again, once we save this and we do this, the same thing that we can do with the other one is we can come in and we can go and create data view with that information on it, create a process control and a data view on there, and get the information needed in process control. This information then, again, like I said, you could go and set up a limit report. One of the things I've done for some clients is set up a limit report with design criteria, not necessarily permit limit information, but design criteria. It'll tell you then in a list, how am I doing? How are my removals? How are my detention times? Based on design of the treatment plant. Again, to give you your overall efficiency of that treatment plant and how it operates. Now, one of the things that we're going to do next week, and I wanted to remind you, next week what we are planning on doing is covering custom formulas. We will actually go into the formula section because, like I said, some of these formulas may not work for you. For example, the FM ratio, we base it off of BOD or CBOD. Well, your plant may base it off of COD. So you want to be able to change that formula and write a custom formula for that. Well, next week what we're going to do is we're going to go in and we're going to go through and look at formulas completely. We're going to go through how to write custom formulas, how to attach them to a given parameter, location parameter, how to test them. I'm also going to give you some unique formulas on some shortcuts on how to come up with some various ways of writing it to make it easier. We will be going over the function help file with formulas. Also, and I want you to remember this, if you go out, and we discussed it last week, if you have a custom formula that you would like to see as an example, if you could write out that formula and you go ahead and email it to the email that's on your screen there, the gototech@allmacsoftware.com, just put in attention formula, webinar formula. If you go and you put that in there, and you can have it to me by the Friday of this week, the end of Friday, I will do my best to try to get those examples put in to the presentation next week so you can actually see how some of those are working. So if you have a formula that's been giving you a little bit of fits, not sure how to do it, here is your opportunity to go in and do it. And so with that, I mean, again, we have questions and stuff. One of the questions that I have coming in is, somebody asked how to add an image to the dashboard like I've done here. This is actually fairly simple to do. I can show you this real easy. It's not covering what we're doing, but to add an image to a dashboard, if you go into the view and you have your dashboard and you want to put an image, kind of like I did with our plant diagram, which one of the benefits to this is I can then put hotspots on this if I want to. If I want to add an image, all you have to do is go to the page and go to options. At this point, you can go and grab your image that you're wanting to look for. Pick whatever image you want. You can grab whatever images you have. Again, don't have any images right now, but you could grab an image, save it here. It'll tell you ask you how you want to save it, whether you want to save it in the top left corner, the centered page, or fit to the page, whichever. Put that in there, save it. It then will show up on your background. So for example, I did the plant diagram. I can put that in there. Benefit of that, hey, like I have my plant diagram here, and we've seen several facilities do this, where then they'll actually go and create a desktop hotspot for their data view. I'm not going to show the image on the hotspot. I can then go and put it right here. And so then somebody comes in here, oh, I want to look at the raw data. I can click on it and I can go in and go from there. Again, that's just a little added bonus for today on that. But again, if you have any questions, we will still be connected for a little while. If you have some more questions that you want to add to the chat, feel free to do so. Besides that, thank you so much for coming today. And again, if you have any samples, formulas you want us to look at next week, feel free to email those to us. I'll do my best to put those into the presentation next week for some formulas. So with that, thank you very much. I hope you all have a great afternoon.